Welcome to Study Loop.
Okay, in order to answer this question, let's remind ourselves what a z-value is, or what a z-score is. So if I'm looking here, I'm going to go ahead and sketch a normal curve, or what's close to a normal curve. I'm going to draw a dotted line right here down the middle where the mean would be. So if I have a set of data or a set of values that can be modeled using a normal distribution, a z-score tells me how many standard deviations a value is away from the mean of that data set. So if I have a z-score of 1, that means that value is going to be 1 standard deviation away from the mean. A z-score of 2 would mean I have a value that's 2 standard deviations away from the mean. -1 would be 1 standard deviation below the mean. -2 would be 2 standard deviations below the mean, etc., etc., etc. So let me kind of erase this here and redraw my normal curve. So notice when I draw my normal curve here, when I draw my normal distribution, I have this curve here, and I'm going to go ahead and draw this dotted line to represent the mean. Notice that 50% or half of my z-scores or my z-values are going to be lower than this point right here. This mean point right here, the z-score right there represents 0 because I'm 0 standard deviations away from the mean. 50% of my z-scores are going to be less than that. So the probability, let me write it this way. You don't have to write it this way, but the probability of having a z-score less than 0, probability of having a z-score less than 0 is going to be 50%. The probability of having a z-score less than 0 is 50%. Okay, so what we're asked to find is we're trying to find the z-score where 54.78% of the area under the curve is to the left of that z-score. So this is the first part of our problem. So if you look at my normal curve, 50% of my z-scores, or 50% of the area under this curve, is going to be left of 0. 54.78% of my z-scores are going to be less than maybe this point right here-ish. Okay, so 54.78% of my z-scores, or 54.78% of the area under this curve, is going to be to the left of this z-value right here. Well, conveniently, we have a way of finding what that z-value is based on this percentage. So either in your textbook, or if you are to look anywhere on the internet, just search like z-score table, you'll pop up with a bunch of different z-score tables. A z-score table is basically a table with a bunch of z-values, a bunch of z-scores, and the corresponding areas under the curve to the left of those z-scores. So here I have this percentage, 54.78%, or I'm going to write that as a decimal, 0.5478. So if I go to my z table, and again, you can pull up a z table in your textbook or on the internet, I'm going to go to my z table and find in the meat and potatoes of my z table, I'm going to find the percentage or the value 0.5478. And looking at my table, conveniently, I can see a value exactly that's 0.5478. If I didn't have a 0.5478 on there, I'd find the value that was closest. But I see that the z value associated with that percentage, 0.5478, is 0.12. So this z value right here is 0.12. And 54.78% of the other z values, or the area under this curve, is going to be to the left of that point under the normal curve. Okay, that was the first part of my question. The second part of my question says, I want to find the z value where 69.85% of the area under this curve, or of the other z values, are to the left of this z value. Okay, well, 69.85% can be written as 0.6985. So I'm going to go ahead and find 0.6985 on my table of percentages. 0.6985. Let's see. I have 0.6985 right there. I can see it. It's going to be up towards the top left corner of the positive Z table. And the Z score associated with 0.6985 is 0.52. The Z score is 0.52. So let me erase this part of my table a little bit. So 69.85% of the area under this curve is probably going to be to the left of, I don't know, maybe this point right here. And the Z-score associated with that percentage is 0.52. So when I have a Z-score of 0.52, meaning 0.5 standard deviations above the mean, that means about 70% or 69.85% of the area under this curve is going to be to the left of that Z-score. Okay, the last one we're asked to find is the Z-score associated with 88.10% of the area under this curve being to the left of that Z-score. So I'm going to go ahead. If I write that as a decimal, that's 0.8810. I'm going to find 0.8810 on my Z table. I found it. It's kind of middle top to the right of my table. 0.8810 matches up with the Z-score of 1.18. 1.18. So again, if I'm looking at my normal curve over here, 1.18 might be, I don't know, over here-ish. So 88% of the Z-scores in this curve, or in other words, 88% of the area under this curve is going to be to the left of that Z-score of 1.18. So that's how I can determine a Z-score given a certain percentage of an area under a curve to the left of that Z-score.